This is 2.6. Today we're going to be, I think, learning something new. I don't think you guys did this in Math 2. A new way of factoring and a new way of solving them. So we're going to both factor and we're going to solve what's called the sum and the difference of cubes. 2 cubes, to be specific here. Okay, so go ahead and write that down. If I asked you to factor x cubed plus 8. If I ask you to factor that. Okay. I'm going to show you this amazing calculator. It's called a TI-89, and it can factor, it can FOIL, it can do all these things, which is pretty cool. So I'm going to ask it to factor, and some of the notation's a little funky here, but so the second thing here is to factor. That expand actually is to it'll multiply out, it'll FOIL for you. Okay, so I'm going to factor, I'm going to have it factor x cubed the way you have to do it on the calculators. You have to do the little caret, okay, plus 8, and then I have to tell it to factor it in terms of x, so that's what that minus x means, comma x is. Okay, so here's what it says it factors into. X plus 2 times x squared minus 2x plus 4. Okay, so that's what this calculator is telling us that this factors into. Can you write that underneath here? X plus 2 times the quantity x squared minus 2x plus 4. Okay, I would like for it also to factor x cubed. Can you give me another perfect cube? 8 is 2 times 2 times 2. Can you give me another one? What's 3 times 3 times 3? 27. So I'm going to have it factor x cubed plus 27. Now I'd like for you to guess. What do you think was going to change here if I had it factored into x cubed plus 27? You think it's, instead of here being x plus 2, you think it's going to be x plus 3? Okay, and then do you think this is going to change, the x squared? So we're guessing here. What do you think this is going to be? Minus 3x, and what do you think the last thing's? Okay, so let's see. I'm going to have the calculator do this. So F2 factors, the second thing, right? Can you see it? X cubed plus 27. I have to tell it, comma x. Is it what we thought? X plus 3, x squared minus 3x. It's putting decimals after this, but that's just 3.0. 3 times x. Yeah, that's what we thought. Okay, So based on that, what do you think x cubed plus 64 would factor as? What do you think it would start with? X plus 4. Jedrick? Okay, join us here, please. What do you think is going to go here?
X squared minus 4x plus 16.
Were you seeing if your calculator could factor? Yeah, cool. Does it? Does yours factor? No, most of the scientifics don't. You have to have this. In fact, even this big graphing calculator doesn't. The 84 doesn't, but the 89 does. Yeah, that's what that factors as. Okay, now, what do you think if I change the sign to minus here? What if it was, so let's go back to x cubed. What if it was minus 8? You want to make a guess? Do you think that would change anything on the factoring? Do you want to see it or do you want to make a guess? You want to see it? Okay, let's have the calculator factor x cubed minus 8. It's x minus 2, x squared plus 2x plus 4. Okay, so let's write that down. X minus 2, x squared plus 2x plus 4. Okay, so look at how this guy factored. Compare these two. What changed? The signs changed, right? This became minus, this became plus. Okay, so guess then, what do you think x cubed minus 27 would factor into? X minus 3, go ahead. And then what? X squared plus 3x plus 9. Yeah, that's what that would factor into. Okay, you guys have kind of discovered how we'd factor these now. I'd like to do it in general. What if it was x cubed plus y cubed, and then I want to factor what is x cubed minus y cubed. Okay, x cubed plus y cubed. When this was x cubed plus 8, this became x plus 2. What are those numbers in relation to the x cubed and the 8? You know, so if this is x cubed plus y cubed, what am I going to have here? In the first parentheses, this was x plus 2, so what's this going to be? I can't make the calculator factor this, I don't think. What do you think it's going to be? X plus y. Yeah. Okay, so we had x plus y, and then this first thing was x squared, right? And for all of these, when this sign was plus, this next thing was minus, right? So it's still going to be minus. Now, this was 2x, this was 3x, this was 4x. What's this going to be? Yx, or we usually put in alphabetical order though, xy, same thing, right? Yeah, but it's these two guys multiplied together, right? It's these two multiplied together with the opposite sign. Okay, and then notice this was plus 4. How could we get 4? Okay, and then we got 9, and then we got 16 here, and so Ashlyn sees it, she says it's plus y squared. Yeah, that is how you factor that. Okay, what's going to change here? The signs, right? This is going to become x minus y, x squared plus xy. What about this last thing? It's positive, right? Okay, that's how you factor. This is the sum of two cubes. This is the difference of two cubes. This is how you factor it. Now here's the rule that we use for this. A little acronym that I don't know who to give credit for, but they came up with SOAP, S-O-A-P, and it stands for all the signs, okay? So here's how it works. The S in SOAP stands for the same. If this is a plus, this is a plus. So put a little tiny S over that. That's the same. And notice when it was a minus, this was a minus. It's the same, okay? O is opposite. If this is a plus, this is a minus, opposite sign. If this is a minus, this is a plus, opposite sign. And then the AP actually stands for this. What do you think that's going to mean? Always positive is what that stands for. So that's kind of cool. SOAP, we're going to SOAP these. We're going to say, SOAP it, where you do the same sign, opposite sign, and then always positive at the end. Okay, and then notice what these are, okay? This is the cube root of this number, right? This is the cube root of this number. This is this guy squared. This is these two guys multiplied together with the opposite sign. And then this is this guy squared. Okay? So let's practice doing some factoring. The directions are going to be to factor completely. Of course, they're going to get, you know, just throw in some extra terms and that type of thing, but you're going to follow the same rules. Okay? So factor this completely. X cubed minus 125. You know, it would also be helpful on this, you guys. Can we just write out a few of the perfect cubes? But to be able to recognize this, you got to recognize these are cubes. 1 times 1 times 1 is 1. What's 2 times 2 times 2? What's 3 times 3 times 3? 4 times 4 times 4? 64. 5 times 5 times 5? 125. Anybody know what 6 times 6 times 6 is? What is it? 216. Yeah. These get a little bit trickier. 7 times 7 times 7. Anybody know that one? Trying to do it? Alina, punch it in your calculator. What's 7 times 7 times 7? 3. 7 times 7 times 7. 343, yeah. Okay, how about 8 times 8 times 8? 512. And how about 9 times 9 times 9? 81 times 9? 729. And then 10 times 10 times 10? 1,000. Okay, so there's some perfect cubes. that we might look for. Okay, so 125 is a perfect cube. So this is the difference of cubes. You're going to think SOAP. SOAP goes, I set it up, this is a binomial, this is a trinomial. Okay, so binomial, trinomial. Okay, it goes the cube root of each of these in here, so x, and the cube root of 125 is 5, and then the sign is the same sign, right? Then it's this guy squared, opposite sign of these two multiplied together, always positive, this term squared. Okay? That's, again, the thinking when we get away from this. Okay, let's try this one. X cubed y cubed plus z cubed. X cubed y cubed plus z cubed. So this is how you're going to recognize this. You're going to look at, oh, that's the sum of two cubes. This is a perfect cube, and this is a perfect cube. Okay? SOAP. SOAP is a binomial and a trinomial. Okay? The first term is the cube roots of each of these. What's the cube root of x cubed y cubed? xy. Yeah, xy. And then the cube root of z cubed, of course, is z. Same sign. Okay? Then what goes first here is this, you square this xy. So you square them both, right? X squared, y squared. Opposite sign. The next thing is these two multiplied together. So x, y, z, just multiply it all together. Always positive. Last term squared. That's the pattern. Anybody seen this before? Done this before? So this is new for everybody? Okay, let's try another one. 4y plus 108 y to the fourth. 4y plus 108 y to the fourth. Okay, so the first question is, are these perfect cubes? 4 is not a perfect cube. Y is not a perfect cube. 108, no. 64 and 125. 108 is not one of our perfect cubes. Okay, so we have to do something else first. So let's go ahead. GCF. Do you know how to tell if 4 goes into a number? Anybody know? If it goes into the last two, it's going to go into it. Does 4 go into 08, which would just be 8? Does it go into 8? Yeah, so 4 goes in. So we can pull the 4 out, and we can pull the y out. So factor out the 4y. What's left here? A 1, right? Okay, and then how many times does 4 go into 108? 27. Okay, and then if I pulled a y out, I'd have y cubed. Okay, now you'd have to see those are perfect cubes, right? Okay, so we're going to SOAP that part. You just keep the 4y, just carry it down. Set up the binomial and then the trinomial. Okay, and it goes the cube roots of each of these. What's the cube root of 1? 1. Cube root of 27 is 3. We'd have 3y. Question? Okay, same sign, right? And then square the 1. What's 1 squared? 1, right? Multiply these two together and opposite sign, so minus 3y. Always positive. Square this. What's 3y quantity squared? What is it? Got to square both parts. Savvy? 9y squared. Yeah. Square the 3 and square. And then that would be factored completely. You guys, this trinomial here never factors. Okay, so don't waste your time trying to factor that ever. That never factors. Okay, the second part of this is going to be to find solutions, and I think that, let me see what's on this. Okay, you guys, I'm going to modify this assignment just a little bit. Okay, just a little bit. When you get to, and we're going to do part of 2.6. We're not going to do the whole thing. Good news. For right now, so we'll have to finish the rest of 2.6 on Friday. Okay, but you're going to do 1 through 6 just like we've done. For the rest of them, for 7 through 12, all I want you to do is come up with the factored form here. We're gonna learn how to do the solutions on Friday, because I wanna be able to do something else today, okay?